to talk about mocking, but more so what I want to do here is show a little bit about how to do test-driven development. One of the challenges we run into often is TDD is something we all have a good desire to do, but oftentimes we tend to kind of give up along the way when things become a little bit more complex. What I want to do here is to show how we could actually manage this with the mocking, but of course mocking itself could turn into a difficulty along the way. So we'll talk about some of the techniques we could use. I want to mostly build an example, play with some code. So I'll talk for maybe about 5 minutes or so, and then we'll get into some code examples and work with it. Best time to ask a question or make a comment is when you have it, so please don't wait till the end. Anytime is a great time for questions or comments. If you do have a question or a comment, the chances are if you raise your hands, I may not actually see you, even if I'm directly looking at you. So draw my attention, say a few words, attract my attention. If I'm not responding to you, that usually means that you have not drawn my attention. Just start speaking or say, whatever, just draw my attention, and then I'll be able to respond to your questions. So let's talk a little bit about unit testing itself. One of the benefits of there are two benefits of unit testing. One benefit of unit testing is it gives us a quick feedback. Not only that the code worked once, but the code continues to work as the design and the code change evolves. The other benefit of unit testing is it gives us a way for us to approach tactical design, a way to design the system. And unit testing makes it really possible to design the system in a way that it is very modular, it's very cohesive, and also it helps us to decouple the dependencies. So there are several benefits to unit testing, and yet a lot of times we don't tend to do it for various reasons. It is partly a discipline. It requires quite a bit of discipline for us to do unit testing. Unit testing is very easy if the code we are trying to test is fairly isolated. If the code has no dependencies at all, it's very easy to write unit test on the code. There is really nothing that stops us from writing the test, and we can easily start writing test and then implement the code. But unit testing often is very difficult if the code we are trying to test has dependencies. And the minute the code that we are testing has dependencies, it becomes really hard to separate those dependencies. And how do we really work with this dependency, especially when the code we are depending either is very complex or its behavior is rather unpredictable. For example, you may call a piece of code and you quite don't know what response it may give you. It may be some value that it may return based on a certain input or a certain time of the day. How do you really predict what this code is going to do? So oftentimes we find it rather difficult to unit test with such dependencies. So this is where mock objects can come and help us. So what's a mock object? A mock object is an object that stands in for a real object. And so when we are testing a piece of code and the code has a dependency to another piece of code, we mock away that dependent code. So as a result, we can quickly go ahead and write test on the code we are testing or developing. And in fact, we can even defer the development of the code that we depend on. We can fill in the details later on. So a mock object stands in for a real object. Not only does a mock object help us deal with behavior, a mock object can help us to deal with ill behavior as well. For example, let's say that I am preparing code for an order processing system, and I need to talk to, let's say, a system that provides credit card processing. And my goal is to make sure the code works properly, not only when the credit card processing system works properly, but I need to make sure that code is working properly even when the credit card processor would return an error back. But how do you simulate or make the credit card processing system return an error back? A lot of times the system is very reliable, except when time it is down, you want to make sure your code handles it properly. So one of the things you can do with mock objects is you can set up the mock object in a way that the mock that pretends to be the credit card processing system can misbehave and return error conditions for you in a rather predictable manner so that we can write our test cases and make sure our code is able to deal with these properly. So those are some of the benefits that mock objects can give us. Now, just to quickly address this, there is a distinction between stubs and mock, and I'm not going to go into the distinction between them very often because I tend to use these two terms fairly interchangeably. But just to kind of set the record straight, there's a difference between a stub and a mock. A stub basically stands in for another object. On the other hand, a mock will actually monitor a set of interactions. In other words, a stub is useful to stand in place when we are interested in testing the state of something, whereas a mock is more useful when we are interested in testing the behavior of the code we are trying to test. So technically speaking, a lot of times we can get away by using a stub, but sometimes it's useful to use a mock object. A mock object will tattletale. For example, you can go to the mock and say, did the code I am testing call you in a certain manner? Did it call you with these input? Did it do these things? And the mock object will come and report back and tattletale to you saying, let me tell you about the interaction that happened. And so if you really want that kind of behavior, a mock object is more useful than a stub. But like I said, I often tend to use these words kind of rather loosely. So you will hear me mostly use the word mock, but that doesn't mean I'm specifically using this definition of mock. I use the word mock for both stubs and mock interchangeably, and I'd rather not, spend my time spinning my, thought as to say, oh, this is a stub, whereas this is a mock. I really don't care most of the time, as long as I know what I'm trying to do. So we'll look at mock objects. So we'll first look at how do we go about using some of these things. But the first thing I would recommend is, in today's talk, mostly I'm going to use mock objects. However, I do want to emphasize that it is very important to avoid using mock objects as much as possible until you have a situation where you can really not avoid it. The reason I mention that is you could quickly get into a mocking hell when you have way too many mock objects to deal with, and it can become very difficult to write and maintain these unit tests. So my first recommendation is to remove the dependency anytime you can, rather than having the dependency and knock it out. This reminds me of an experience. I was in a conference called the Software Design and Testing Conference a few years ago, and one of the topics people were talking about in the conference was how they really like unit testing, but mock objects really make it very difficult for them to write their unit test and maintain it. And one of the things I observed in the conference during the discussion phase was, I said, maybe you're having these difficulties because the design is really rather, not good. And of course that led to discussing, how we would rather design the system. And one of the realizations was that people often tend to carry a lot of dependency in code when we could actually get rid of those dependency. So people often ask me, is this a case where we should do inversion of control? Should I invert the dependency and then mock it out? My suggestion is not to use inversion of control when you actually can remove the dependency in the first place. So I would say knock it out before you mock it out, meaning it's better to remove dependency, then you don't have to mock at all, and then only when you cannot remove the dependency do you want to bring in inversion of control and then mock. So anyway, I want to just kind of mention that because I don't want you to go away thinking that mocking is the right answer for a lot of things we do. The other thing I want to also mention here is, oftentimes it's nice to do a top-down design. And the reason why a top-down design is really useful is we can start with a higher level of problem, and then we can drill into details gradually as we explore the problem further. So a top-down approach is very useful in conceptualizing a problem and then getting into details, and only when we really need to get into those details. Now, having said that, a lot of times when I do test-driven development, I tend to kind of abandon top-down design, mainly because I don't find it easy to write test cases on a piece of code when the code it depends on has not yet been created. So I would kind of start at the top level, but go through a thought process, and then I may tend to really create tests at the bottom level and build it back up, which is rather frustrating when you do that, because you really want to conceptualize and drill down to details, but there seems to be a bit of a lacking effort in going to write test cases. If we can effectively find a way to mock, then a top-down design is very practical, and I'm going to use it with an example where I'm hoping that I'll be able to create this example completely test-driven, meaning that I will not write a single line of code until we have a failing test for it, and then we will drive it top-down. So let's look at an example of how we could do a top-down development, but for that I need to start with a problem, an example. So here is a problem I'm going to start with. So imagine for a minute, I'll set up an example real quick, and then we'll get into the details of how we will solve it. So suppose there's a company that wants to sell currency. I travel internationally a lot. Almost every week I'm in a different country. So for me, exchanging currency is something that I have to do constantly. So a company wants to sell currency. So I could go give US dollars and they could give me the local currency. Maybe I want to get pounds for US dollars. But they have a service, and assume that this is a service that's available in a certain URL, and the service will, given a vendor name and a currency name, will tell us how much price that vendor is willing to pay for the currency. This company actually wants to just be a wrapper around the service, so they want to sell you the currency for a profit. So the way they're going to do this is, let's assume for a minute there are 5 vendors interested in selling currency. This company is going to go find out what each of these vendors are going to offer, right? One vendor may offer, $2 per a pound. Another may offer $2.50, what have you, right? So they'll go back to these and then say, given these different currencies, they're going to find the highest paying vendor, and then they're going to take away 2% from the rate because they have to make a profit, and then they're going to give you back that rate and say, that's our best price for you, would you like to buy it? So I want to create a code that will automatically go to the web service, ask for the price for each of the vendors, find out what the price is, compute the highest price among the values available, subtract 2% from it, and then give you the price. So that's kind of what I want to do. Sounds reasonable? Okay, so let's see how we're going to start with it. I'm going to do test-driven development on this problem. There are a few issues we have to deal with. The service mostly returns a value as a string, but occasionally it can return garbage for us. So we got to do some error handling as well. So let's see how we're going to do any of these. When I start really writing unit tests, I normally start with what's called a canary test. A canary test is a stupid test, which is basically an assert true is true. This is just to see if the tools are set up properly and the environment is set properly so that we can get going. So I normally start with a canary test. So let's start with a canary test, and so we can kind of familiarize ourselves with how this is going to look like. So what I'm going to do here, I have a little class here called currency exchange test. It doesn't have anything right now, and I'm going to start with a little canary test, as you can see here, and it's going to be test canary. And all that I'm going to do in the canary test is I'm going to say assert is true, and I'm going to simply tell him that this is false to begin with. Obviously this is wrong, and I want this to fail. So I'm going to go ahead and run this little test at this point, and I'm going to make sure that my test is failing, and that can be a quick feedback to make sure the tool is set up properly and I can get going from here. So I'm compiling the code, I'm running the test case to get the feedback, and of course it's warming up. It's going to run the test for me, and on the left side it's going to tell me that the test failed, and it's in color right now. It's probably a little hard for you to see from there, so I will say what the test is doing, but you can see that my canary test actually failed right there. So that tells me that this is not working. So let's go ahead and modify this. I say that it's going to be a true this time. I'm running the test again, and you can see that the test is passing, and it's a green right now. I'm not going to zoom in constantly for you, but I'll tell you whether the test is passing or failing. Maybe people in the front row are able to see that with their squinted eyes, and you can confirm that I'm not lying, right, as I'm saying what this is doing. So we have a little canary test that's running here, and that's what we did. But I want to gradually start with this, so I'm going to add a first test for a markup, right, or markdown rather. Remember, the code is going to mark down the price by 2% and give you the price, so maybe that's a good test to start with. So let's start with the markdown. So what I want to do here with the markdown test is, I'm going to start with a little test here to say that when I use this, give the price value, I want to mark it down. So how would I go about with the markdown itself? I'm trying to get this a little bit up here for you to see better, so let me see if I can do that. So essentially the idea is that you really want to start with some basic tests, but as gradually progressive as you can to get to real parts of this. There we go. So let's kind of look at, this doesn't want to stay up here. All right, so what do I want to do here? I'm going to write my next test up here, and the next test that I want to write here is going to be, come on, the tool is misbehaving here. So the next test I want to start here, let's start with a test called markdown. And what does this markdown do? So I'm going to start with the currency exchange. So let's call it currency exchange. That's an object that I'm going to use. And I'm going to call this as exchange equals, let's call new currency exchange. And this time I'm going to simply say assert R equal, and I want to get a price of 98 when the exchange will mark down a price of 100, because we know that 2% of 100 is taken away from 100 is going to be 98. So I need this currency exchange object. So I'm going to go ahead and create a currency exchange. Well, that already is in the second library that I have here. That library is called currency exchange lib. So I'm going to use this library. So how am I going to go ahead and build that up into here? So I'm going to just add a reference to it. That's all I did. I put a using on the top. And now I'm ready to go ahead and build this markdown code. So let's go ahead and ask him to generate the markdown code. So I'm just using Visual Studio to go generate it. Now at this point I can go to the other class. You can see the markdown method being created right here. So I'm going to tell him that it needs to return a double value for me, and the amount I'm going to specify is going to be a double amount as well. And of course I want this code to return to me a value of, let's say, amount times 0.98%, right? So that's all I want to return a percentage value. Let's go ahead and run this test one more time to make sure the test is passing. You can see the two tests are passing now. The markdown is passing, and the guys in the front row are nodding to make sure that I'm actually saying the truth. Absolutely, that it's passing. You can see that. But I want to start again gradually. What if I don't have any vendors? Now, what is the benefit of some of these beginning test cases? The benefit of some of these beginning test cases is twofold. The first thing is, I like to gradually write the test cases because the first few test cases may appear a little trivial, but these test cases actually help us to define the skin of the interface, the object, and then further down as we write more test cases, they help us to define the guts of the object. In other words, we kind of go from forming what it should do and then slowly growing into how it should do it, which rather makes really good sense if you think about object-oriented programming, because the real key about OOP is that you can vary the implementation of objects once you define the interface of the object in the first place. So the real objective here is to take the first few test cases so we can build the skin of the object, and then later test cases will help us to refine the implementation, which of course can be varied as we get a better understanding. So what I'm going to do here is to start with the first no vendors. Now of course the question is, what does it mean that I have no vendors? Well, if I don't have any vendors for whatever reason in the code, what do I want the code to return to me? Well, to the user of the application, it doesn't care they don't care that you don't have vendors. What they care is what price you're going to give them. So I'm going to say no vendors over here, and what they care is if you don't have a vendor, they don't really care to know that you don't have a vendor. All that they care is that you don't have any price to give them. And of course, if you go to the market and say, I've got $100 US, what can you give me? And they say that I'll take all your money and give you nothing, you're going to say thank you, no thanks, and walk away, right? So 0 is a good result to get to say that something is wrong, we're not in business today. So the idea really here is that I'm going to go ahead and use the currency exchange right here. You could move this to the setup method if you want to. I'm not going to do that right here in this example. So I'm going to say create the currency exchange, but once I get the currency exchange, I'm going to say assert R equal, I want a value of 0, and I want the exchange to get me a rate, let's say for GBP. So in this case, since I don't have any vendors, I want the result to be a 0. So I'm going to go ahead and implement this example here. So going back to the code, I can define the interface of this. I want this guy to return to me a double value for the rate, and I want him to take as an input the currency that he's going to use. And we want to write minimum code to make the test pass. So all that I'm going to return here is a 0 for now, because that's more than adequate to make the test pass as we have it right now. So I'm writing this code, running the test, and oh, I had made a mistake. It tells me that I have something wrong here. Let me go ahead and fix that error. It tells me that a parenthesis is expected. Absolutely, I forgot to put that here. Let's go back and run the test, and we can see that in this case 3 tests are passing. The first Canary test, the Markdown test, and of course the no vendor test is passing as well. So what did that do for us? It helped us to define the interface of the code. It helps us to define a behavior when we don't have any vendors. Now it's time for us to define one vendor, which really takes us into a bit more complexity. Now, if you notice, I didn't start with complexity. I kind of walked a little bit before I'm starting to run towards complexity. And one of the reasons is, how do we really approach solving a problem? How do we approach design? So think about this as your unit test should take you from something that you don't know to something that you know. But remember, when you start a problem, there is a lot of things you don't know. And the worst way to solve a problem is to take 20 things you don't know and try to solve all of them at one time. And the minute you do that, we get confused and we end up wasting a lot of time. So one of the ways to solve problem is to say, here are so many unknowns, and as intelligent as I am as a human being, I know that I can solve multiple problems in one sitting. So I'm going to take these problems, but I'm going to take one unknown and the smallest unknown that I know and convert it to a known, and then go to the next unknown and convert it to the known. And in other words, the effort in test-driven development is to take a transformation from one unknown to known, one at a time gradually. So by the time you get to other unknowns, you would have solved quite a number of problems along the way. So we did solve quite a few unknowns along the way, defining the interface, what should the code do when we have no vendors. Now we are at a point where we have to talk to more vendors. How am I going to do this? So I need to write a test first of all, and the test here is going to be one vendor, right? Rate with one vendor. So what am I going to do with the rate with one vendor? Now, of course, you could properly name these methods if you wanted to. You could say get rate with one vendor. That's perfectly fine. So I'm going to create a currency exchange one more time. And in this case, of course, I'm going to say new currency exchange. And I want to say assert or equals, I want a price of 98 when I call the exchange get rate for, let's say, GBP this time. Now, remember, in this particular case, I do have one vendor. But what do I tell him that I have this one vendor? So I'm going to say exchange dot, let's call it as set vendor. And let's say vendor 1 is what I want to set to this, to say that I have a one vendor. We'll refactor this along the way if we have to, but this is a good starting point. So I'm going to create this function called set vendor. So if I go to the class here, the set vendor says, give me a vendor name. So I'm going to just say vendor here. I'm going to leave this empty for now. I'll worry about this a little bit later, come and implement this. So I'm going to go back to the test itself now. And in the test, I'm going to say, given this one vendor 1, I want to know that the price is 98, but how do I know that the vendor 1 is going to give me a price of 100 rather, right? Because I have to mark it down and return the price. But I got to tell that somewhere. You could say, why can't you go talk to the real web service? Well, you see, we don't have a clue what the market rate is. We don't have a clue whether the vendor is there or not. So there's a lot of unknowns and very unpredictable. You cannot write a test predictably with the data that changes so often. So if you're going to talk to the real web service, whatever result it returns, there is no way to write good test. And oftentimes what you will see people do is they will write silly tests like assert greater than 0 or assert true, and it annoys me to no end when I see tests like that, because you want tests to be very predictable and deterministic, and you don't want to write vague tests like greater than 0 or not a number and things like that. You want to get really close to what it should be. So in other words, what we're going to do here is to mock it out. Now, how are we going to mock this out? Well, this is where dependency inversion can help us certainly. So I'm going to go back to the code, the class, the project here. I'm going to go ahead and create, I'm going to say add class. Well, actually, I'm going to add an interface rather here. So I'm asking him to add an interface. And in this case, the interface I'm going to create is called iVendor rate service. So there is a vendor rate service. I'm asking him to create an interface for iVendor rate service. And what kind of method do I want this to have? I want him to return a double value, get rate for a vendor and currency, right? So this is the method I'm interested. Given a vendor name and given a currency name, I want this to return to me a rate for that vendor. So this is the method I'm going to use. Of course, this may be the real method, or it could be a method that you can transform using an adapter pattern. That's up to you in your design decision. But that's the interface that I just created right here. Now let's leave the interface alone. We don't need to look at it right now. But I need to use that interface in the code. How would I go about using that? So I'm going to say over here, vendor rate service, let's call it service equals null for a minute. And I'm going to pass the vendor rate to the constructor over here as vendor rate. So there are a couple of options available for us. Now, in case of dependency inversion, there are two things you could actually do. The first thing you could do here is you could say, I could inject this dependency in three ways possibly. One way to inject dependency is to use a factory. In other words, you call a method, and within the method, it calls out to a factory and says, hey factory, can you give me an object? And depending on the context of execution, whether you're in integration mode or testing mode, it can create an appropriate object and return back to you. So that is an approach you can use, a factory. And I rarely use factories like that because I am fundamentally a lazy guy. That requires more work, and I usually avoid more work. The second way to do this is to write setter-based injection. You would call the method and you would say, I'm going to call a set, some context object, and then the setter-based injection can be used. And that is not a bad idea. A third option is to use a constructor-based injection, which is what I'm doing here, where when you use the constructor, you can tell him what service to use. As you can see here, the code is already complaining because we don't have a constructor that takes a parameter. So I'm going to fix it real quickly. I'm going to go to this class. I'm going to first create a constructor here, which doesn't take any parameters. Now, why am I writing that constructor? For a couple of reasons. The first reason I have this empty constructor is I already have two test cases which are not using the service vendor, and those test cases can still use this constructor. The second reason I'm using this constructor is eventually when I go into a real integration mode, even though I use one of these three ways of injecting the behavior into this code, the dependency into this code, I don't want my code to be burdened by this dependency in a normal development manner. So my test cases can use the second constructor to inject the dependency, but my real code could use the first constructor to use the direct object and don't have to worry about injection. So I normally would just go ahead and plug in the real service here when I begin to use it. But I'm not going to use that in this example right now. If we need to, we can get to it later on. So the second constructor I'm writing here is going to take the vendor service, and I'm going to call it as service over here, and I'm going to simply set up that the service I'm going to use here is going to be the service object that I just received, and obviously I need to store it away. So this is vendor service, service, I'm going to set that service into the object. Okay, great. So how would I then mock out that service? Notice I set it to null just for a minute while I was working on it, but I have to really create a mock. Now there are three ways to create a mock. Well, actually 2 ways, 2.5 ways. So the first way to create a mock is to hand toss a mock object. And I normally do this. By the way, I would create a mock object by hand, and I highly recommend doing it because it gives an opportunity for us to really get a good understanding of what we're trying to do without being distracted by the tools in the framework. So normally I would hand toss a mock object, at least in the beginning. I'm not going to do that here for lack of time in this particular session. A second way to do this is to use mocking library, and oftentimes I use something like a Rhino mock, for example, or a Rhino mock, and tools like that can help us to mock away dependencies, and so you could do that. I'm not going to use Rhino mock here, and instead I'm going to use something that's already built into .NET tools. It is called the fakes library, and that gives us some very interesting ways to mock out things. So I'm going to use that, and fakes library gives us 2 things already. One is called fakes, another is called shimming, and we're going to use both of those today to get a feel for it. So let's take a look at how we can use fakes over here. So what I'm going to do here is, first of all, I'm going to go back to the library here, the test library here, and in the test library, I select the library that contains my real code. Again, I'm in the test library, but I select the library, the reference to the library that contains the real code. I right click on this guy and I say add fakes assembly, and this goes and does compile time, a generation, and it creates a fakes library for me. So what Microsoft tool does here is it creates a bunch of stubs for us to begin with. And at this time, it's a good idea to just compile the code one time so that the code compilation goes through and creates the fakes library for us. So now that I've done that, the next step here would be to use that to create the object. So I'm going to say new, and this is the currency exchange lib dot, and notice now there is something called fakes over here. So I'm going to use fakes dot and stub for iVendor service. So I'm asking him to create a stub for the interface that we created in the other library. And so it says, all right, I'll create a stub for you, and I'm going to create an instance of it right here. And in this case, I'm going to say, I'm interested in the one method the interface contains. And you know what that method is, right? It's called the getRate vendor and currency. Now, if you recollect, the method name was called getRate for vendor name and currency. Unfortunately, though, we can overload functions in .NET, which means I could have multiple methods with exactly the same name called get vendor, rate for vendor name and currency. So how do you know which method we are dealing with? In order to deal with that properly, the way the fakes framework works is it tags along the parameter names to the end of this for resolving overloading. So because our method took two strings, it says string in the very end. If you had overloaded this method, let's say you have three methods with the same name, you will have the same name for the three methods, but the end names would be different based on the types of the parameters you are using, purely for overloading resolution, if you will. So in this case, I write that this appears to be a property on the mock object, equals to, and I'm going to simply give a lambda expression here, vendor name and the currency. And what do I want to return from here? Well, I want to return a value of 100. Remember, that's the mock value that I want to return back. So let's look at the test one more time to see if this makes sense. We are saying the currency exchange is going to work with a vendor that I have provided, a vendor service I have provided. I have completely marked out the service right here, and the service now returns 100 no matter what price I ask for. And now in the test, I ask him for the rate for a one vendor given, and he better give me a 98 because he's got to use that service. It returns 100, he marks it down, and it should be a 98. Am I making sense so far? So let's go ahead and run the test and see what it does. And of course, I want this to fail at this point. Let's see if it fails for the right reasons. So when I run this test, it compiles the code. It's going to run this code. It's going to run for this one particular test we just wrote for this one vendor. Let's kind of wait for the test to complete. And so let's see. It's still running. It's still thinking. So right there, it failed. And it failed for one vendor. Why did it fail? If I take a look at the reason for failure, at the very bottom it tells me it failed. Why? Because it said it threw an exception of some kind, threw exception, not implemented exception, of course. And the reason is, in here I did not implement the set vendor method. Let's go ahead and fix it. We can say here, I'm going to put a vendor equals vendor, that one vendor you gave me. I can set that one vendor here as a field for now. So I'm going to say this is one vendor. I'm just going to leave that here for now. Let's go ahead and run the test one more time and see if it fails again for the right reasons. And this time, of course, the test is still expected to fail, but let's see why it's failing. So it's still running. So if I go take a look at the failure message this time, it tells me it failed because the expected value was 98, but the code returned a 0. Which makes sense, right? Because I did not change my real code yet. It's still returning 0. So it's time for us to fix it. So I'm going to say return rate. But what is this rate? So double rate equals 0. And if the vendor is not equal to null, then go ahead and give me the rate for the vendor. So rate equals service dot get rate for vendor and currency, given this vendor name and the currency given to me. And then rate is equal to mark down the given rate itself. Does that make sense? Right? So the implementation now says, go set the rate to 0. if you do have a vendor, then go to the service and ask price for the vendor, and whatever price you get, mark it down by 2% and return that price to the caller. That's all I wrote so far. So if I go ahead and run the code now, you can see at this time that all the tests are going to pass, assuming I did the right things. And in fact, all the tests are now passing because we used the mock to take away the service. So you can see how we were able to gradually move into this, and we completely mocked out the dependency at this point by using mock. Like I said, you could have used Rhino mock or other tools to do this also. So this doesn't mean you have to use the fakes library, but I just use that here to solve this particular problem. So all that I did so far is mock out the service, and we were able to write this. My next test is going to be to simulate an exception. What happens if things go wrong? So what if the vendor is going to return an error for given one vendor? So I'm going to go back to the test, and I'm going to write a test in this case. The test is going to be a rate for one vendor with error, right, from service, right? So error from service. So what's going to happen if the service gives me an error? Well, this is going to be almost the same as this test with a few changes. So I'm going to go ahead and copy this over, and I'm going to say here the result I'm expecting at this time is going to be what? Well, if the vendor fails, I would rather receive a 0 as a price, because the user doesn't care what actually went wrong. And since we only have one vendor, I want that to be the result at this point, right? So that's what I'm asking him to give at this time. So he's telling us that given one vendor, but I have to tell him that it's going to be an exception, isn't it? So rather than the vendor returning 100, I'm going to say that this vendor is going to throw new, and we can say application exception, and we could simply say simulated exception. So I'm going to throw an exception from this particular code by using the throw new. And because lambda expression requires the return value, I got around it by putting a little curly around it. So he's like quite happy that you're throwing exception from this body of code it's executing. So what did I do so far? I created a service one more time. I mocked it away. And in the mock, rather than giving 100 as a result, I throw an exception. Then I come to the code, I set vendor 1, and I ask him for the price. This time the price should be 0 because the only vendor I have still is broken. I cannot get the price from the service. If I go ahead and run this test, I want the test to fail at this point. And the reason this test would fail is because my code is not handling the exception properly, right? So if I go ahead and run this code, I want the code to fail saying, you expected a value of 0, but I got an exception. So right there it failed, and the exception error says you got an exception. So to deal with this, I'm going to go to the code again, and this time I'm going to say, go ahead and call a try on this code, and if there was an exception and things failed, I'm going to say catch, and this is going to be application exception, and I'll just say there's an exception on my hand. And what am I going to do with this exception? I'm going to simply say ignore for now. Now, we all know as programmers, it's morally wrong to suppress exceptions. We know that, right? So ignore this for a minute. We'll come back and fix it later on, but I'm just suppressing exception in this case. So now if I go ahead and run this code, I've suppressed the exception at this point, returning a 0 when there was an exception. So ideally this test should fail at this, pass at this time, and let's see if the test is passing. The test is still running, and you can see all the tests passed. So that seems to have done the job properly. So what did we do so far? We mocked out the dependency, and we wrote 2 tests. In the first test, our mock is returning a 0 for the price value, 100 for the price value, and in the second case our mock is throwing an exception to simulate a failure situation, and we are able to handle both of those cases. So we are able to design our code, and we are able to postpone the real code we have to talk to so that we can focus on the design of our code and pushing away the dependency a little longer. Am I making sense so far? Any questions? If you don't ask questions, I would assume you sent your mocks here today and not yourself, right? So you got to ask the questions along the way or make comments. So that's what we saw so far, right? What about two vendors? What if I want to have two vendors in here rather than one vendor? We could write a test for that fairly easily now, and I could say I have two vendors. So let's write another test here, and I'm going to say two vendors, and I'm not going to write all the test here because I want to get to a few other concepts. But let's start with two vendors real quick. So in this case, I want to write a test for two vendors. Let me make sure I'm in the right place. So let's say this is going to be test for two vendors. And what am I going to do for the two vendors? Let's go ahead and say, first of all, I'm going to say currency exchange, and this is going to be the exchange, and equals to new currency exchange. I got to give him a service. I'll come back to the service in a minute. But then I'm going to say exchange dot set vendors, and I'm going to give him a vendor 1 and a vendor 2 this time. So this is going to be vendor 2. So this is going to require me to refactor the code a little bit. And then I'm going to say assert or equal, and I want the price to be 49, and we'll say exchange.getRate, and this is going to be a rate for, again, the price. I just changed the value a little bit to make sure that it gives a different result. So what is the first thing I need? I need a set vendors method. So to deal with that, I'm going to make a few changes here. The first change I'm going to make here is that this is going to become a collection of vendors rather than being one vendor, right? And then, of course, for that to work properly, I'm going to change this to set vendors, and this is going to be a params, and this is going to take vendor values as a collection of values, right? So this is going to be vendors coming in, and so this is going to become a vendors value as well that I'm going to go ahead and set in here. So now that I've given a couple of vendors to him, we'll come and fix the code in a minute. This is going to take some vendors, and that's the vendors I'm going to pass to this guy, and that's just one vendor here and two vendors here. But how do I tell him what to do for these vendors? So I'm going to create a dictionary over here. So dictionary of what? String and double, and we will call it as rates equals. Let's create a dictionary here, and this dictionary that I'm creating here is going to simply say that it's got a value here of one value, which is vendor 1. So this is vendor 1, and the price is going to be, let's say, 30, and it's going to have another vendor. So this is going to be vendor 2, and this is going to be a price of, let's say, 50. So I've got two vendors that I'm going to send to him. So that's a good start. Now what is the next thing I have to do for this to work? Let's go ahead and satisfy the compiler here using the using. All right, and now that I have done that, the next step here is to provide the mock object that this guy needs. So to provide the mock object, I create the vendor service one more time, equals new, and remember I can simply say currency exchange fakes lib dot fakes dot stub for I vendor one more time, but this time I'm going to say get rate from vendor equals. This is going to take a vendor name and currency, and all that he is going to do is return back the prices for the given vendor from the marked up value that I put up there in the top. So he's going to just return the value based on the price that you are providing, the vendor rate that vendor name that you're providing. So now that I'm returning this value, how does the code work? So let's go to the code and fix it. So what am I going to do here? I have a rate value on my hand. So now I'm going to say for each, and I'm going to start with the vendor in vendors, right? So I've got a collection of vendors on my hand, and for each of these vendors, I need to do my work. So what am I going to do? First of all, I need to get a rate for this vendor. So I'll create a try block, and then of course the catch block, an application exception. If there's something going wrong, I'm going to just suppress the exception one more time here like we did, ignore. But this time, I'm going to say, rate for vendor equals. We can go back to the service this time and ask for the rate for the vendor on hand and the currency on hand. And if, of course, we have to mark up the value, right? So rate for vendor equals, and then we'll mark down the rate for the vendor itself. So we'll say rate for vendor. And now that I've marked it down, if rate is less than rate for vendor, then of course I have to say the rate equals rate for vendor, right? So I'm going to bring that in and use that as the rate that I have to use. So rate for a vendor. Now that I have the rate on my hand, what am I going to do? I'm going to return that rate, obviously, so I can get rid of this part now because I changed that to the new implementation I'm using. Let's see if that's going to work. So I have two vendors. The vendor 1 is giving 30, the vendor 2 is giving 50. The vendor 2's rate is higher, obviously, so after it marks it down, 2% down after 50 is 49. That's what I should get the result as. Let's fix the error that I got here. So let's see what he is complaining about. He says no extension method for this. Vendors, of course. Let's go ahead and fix that. So let's go ahead and run the test and see what the test is doing this time. So this time, of course, I'm using two vendors in my test, and it should tell us that the price is 49, and it's still running. Of course, when it finishes, oh, no vendors fail. Let's see what happened for the no vendors. In the case of no vendors, of course, it should give us a value of 0 when I have no vendors at all. But how does it know that there are no vendors? Of course, when I create this, if there are no vendors, I should set this up to be a blank collection, right? So I'll say string of 0 elements. So this is going to be just an empty collection I'm going to create over here. So let's go ahead and run it and see if it takes care of the no vendors. Otherwise, we can take a look at see what the problem is that he's not happy with it. So so there you go, and the tests are passing. So what did I do so far? All that I did was I took care of two vendors. I'm going to skip a few tests over here for multiple vendors, but let's go a little step further. I want to go further to say, how do I really do a little bit more dependency here? Remember that little thing, the sour code we wrote, where we left the catch block empty, and I said it's morally wrong to leave the catch blocks empty. We're going to go fix it. So what I'm going to do here is to say, okay, the vendor says, you know what, the users can know what the price is when things go wrong. However, if something goes wrong, I want to keep track of which vendor is failing. So I want to write to a log file about the failures. So an admin can look at the log files periodically and go back and take a look at what's going on and maybe resolve the situation, right? So I want to log to something. Now, how do I log? It's easy to go to the code and in the catch block, quickly to say, go ahead and log. So here is the code, and I can take this ignore out, and I can start writing code for logging here. What would be wrong if I do that? If I start writing code right here now for logging? That's right, I didn't write test first. That's correct. So we're going to write a test first before we go write the code for it. So let's go ahead and write the test for it. So how is this test going to look like? So what I'm going to do here is to say log when a vendor request fails, or when a service request fails. So how would I do that? The first thing is, of course, I've got to simulate an exception, right? Well, that's pretty easy because I already have an example that simulates an exception, so I can just grab that example from right here. So I'm going to just go ahead and take this example from here, and all that this does is, when you call this, it throws an exception. You know this, right? So let's grab this one. So I go down to the new test we are writing, and I drop it in here, and notice this guy is throwing an exception when there is an error, right? I'm going to set exchange.set vendors, and I'm going to give him vendor 1, and it's going to fail for vendor 1. So I'm going to go ahead and say exchange.getRate, and get rate for some currency, doesn't matter what the currency is. And now that I call this, I want to assert that there was actually a logging. So my real purpose of this test is to make sure the code is logging things properly. There are two things I want to test. That it wrote to the right log file, and second, it wrote the right log message. So how do I do that? First of all, I'm going to say that I want to write it to errors.log, comma, and I'm going to say log file name. That's the name of the file I'm going to look for. So I'm going to check for a log file name. We'll see how that can be done in a minute. And then I'm going to say assert or equals. I'm going to say error, and then for vendor 1 on, and I'm going to say a date. So today is 5th of May, so I'll say 8/2013, and let's say the time is 10 a.m. So essentially I'm going to say that this is the time that I want the error to be. Now you see there are some problems here. We'll call it as log message. So what is the problem? The problem is we don't have a clue when the error will be there, when the test is run. So if the log file is going to be written with real content, we can never do proper testing with it. So we're going to mark out those things. Let's see how we're going to do that with this example. So what I'm going to do here is, I'm going to first of all go back and call this method, but I've got to tell him what to do the logging with. So to do that, what I'm going to do is essentially to tell him the log file name is a variable I'm going to create. So up here on the top, I'm going to go ahead and create a log file name. So let's go ahead and say var log file name equals empty. And I'm going to create a log message equals empty also. So I've created these two variables just now. Let's go ahead and run the test just now. Let's let the test fail, then we'll come back and see how we can fix it. So I'm running the test. It failed the test. Let's look at the failure message. And the message says, I expected a value of the file name to be errors.log, but it was empty. Obviously it's empty because we set it to empty right here, and it says I expected errors.log. What's going on? So how do I work with this? So notice what I'm going to do now. I'm going to go back here to the library here, and this time I know that I'm going to write to a log, which is a file, but I don't create the file, right? The file is part of .NET API. So I'm going to right click on system, and I'm going to add fakes assembly right here on the system itself. So that creates a systems.fakes. But this time though, I need to mark out a .NET assembly, but unfortunately though, I'm not going to do a constructor injection. I'm not going to pass this through a constructor parameter, right? Because I would be simply using a static method in my code. I don't have a factory injection, I don't have a setter injection, I don't have a constructor injection. What do I do? Well, so we're going to do something a little different than mocking. We're going to what is called shimming in this library. So you kind of sneak under, kind of like using AOP or aspect noted programming, and remove the guts and change the implementation. So how do we do that? So to do this, what I'm going to do is I'm going to first of all say using over here. And in this case, I'm going to say using, and it allows us to run in a certain context. So I'm going to create a context right here. And the context I'm going to create right here is called a shim context. So this is going to be a shim context that I'm going to create here. And the context basically, I'm going to call it as create over here. And this gives a like little environment in which we're going to go ahead and run this particular context of code. So I'm going to do an import for this. This comes from the Microsoft Quality Tools testing of .fakes, and I brought in a context. Now how does this really help? The way this helps is before I call the getRate method, because that's when I'm going to be doing the logging actually. So right before this, what I'm going to do is I'm going to say system dot and then IO, because that's where the library that I'm interested in is present, fakes dot, and I'm going to ask him for a shim for file. So this is basically saying I want to reach into the guts of it and mark out the file. And what am I interested in marking out on this class? I am interested in write and let's say text. So write, what am I interested in writing on the file? So I'm going to go ahead and write, so let's call this dot, and append a text string. How about that? So I want to append a certain text to this log file, and this is the method I'm interested in marking out. Now what does this method really take as a parameter? Well, if you go back and take a look at what he takes as a parameter, you will notice that this particular thing takes as a parameter a path, basically a string path it's going to take. And then of course I want to pass in a little bit of details about the file information I want to pass in as well. Well, let's go back to this file and see what other function I could use. I want to use a write function. I'm trying to think about write all lines. No, I want to write a text actually. Let's see if there is, there's a write all text. Let's take a look at this one here. Write all text is going to take two strings, and what does he take? He takes a path and he takes a message. So let's put those two here. And what do I want to do within this? I'm going to simply save away the path. So log file name equals the path given to me. And then of course I'm going to say message. So log message equals, and then the message that's given to me. So I'm going to store those two away. And so I'm just marking out the write all text file. And once I mark this out, I just call the getRate method. How is this going to help? Let's take baby steps to look at how this is going to help. So if I go back to this test over here, let's try this one more time. In the ignore, I'm going to go ahead and say file dot over here. So file, of course, comes from system.io. Let's go ahead and add a reference to it. Dot, and write all text over here. So write all text. And what am I writing it to? The path is going to be errors.log file. And the message I want to write is something went wrong. So I'm going to go ahead and just write that message for now, right? Not a write message, but let's start with that. So if I compile this code and run it, my test will still fail, but let's see where it's failing this time. So when I run this code, I have reached in and marked this out and substituted this implementation. So if I go take a look at the internals of this now, let's see what this is going to do. It says it failed, but look at the error message it gave us this time. The error message says error for vendor 1 is expected, but what I got instead was something went wrong. So notice how he is able to tell us that it did not get the right message at this time. Let's go ahead and fix something else. What do I want to say here? Well, I want to return over here a string format. So I'm going to say string.format. And the message I want to return over here is something along this line, isn't it? And that is going to be error for vendor 1 on, and whatever the date is, that's what I want to specify over here. So let's see how we can specify that in just a second. So I'm going to go back to this code, and I'm going to say error for, this is going to be vendor name, so that's vendor name, on, and this is going to be the date value, isn't it? So I'm going to replace this with 2. And then I'm going to say comma, and this is going to be the vendor name given to us, and this is going to be datetime.now, because that's when the problem really happened. Now if I go run the test, let's see what's going to happen. If I run the test this time, the test is still failing. Let's see why it's failing. And in this time, actually it's failing 2 tests, unfortunately. Let's go ahead and make sure that I did the right thing here. So error for log, and then it's going to log this one here. So if you look, what did I do? Oh, 0 and 1, of course. See, I'm sleeping at wheel right there. Thank you. So that proves that you actually are awake. That's good. Much awake than me probably at this time. Excellent. So that failed. Why did it fail now? Did you notice the reason for failure? See if this makes sense. The reason it failed here is, it says that I expected error for vendor 1 that day, but error for vendor 1, 5/8/2013, 11:47 a.m. it says, right? Makes sense? Because that's when it failed, not at 10 o'clock like I said. But you can never make this predictable because you don't know when this is running. It's very difficult to time it properly, right? So how do you fix it? So here's the last fix I'm going to make. I'm going to go back to this. Before I call the get rate, I'm going to go ahead and say here, system.shim for fakes dot shim for date time, and the method I'm going to shim here, thanks for the reminder, is going to be get now get, and I'm going to say equals, and what am I going to return here? New date time, and the value I'm going to give to this guy is going to be the current year, by the way, which is 2013. The month is going to be May, and the value is going to be 8th. And the time is going to be 10 o'clock, 0 minutes and 0 hours. So we completely marked out the time is going to use under the covers. And I go back and run the test this time, assuming that I wrote that correctly. And it's going to run the test. Let's fix the error here. He's not happy with what here. So I'm specifying, let's make sure we give all the parameters that this guy is needing. And the second value I want to specify here. So that's the value for this. So this is what he's going to return from here. Did I put a return in front of it? No. So this is the new date time that I want to return. Let's see what the error says here. So in this case, it's telling me that argument out of range exception. So 2013, 5/8. So it probably is a problem because of the values I specify. Let's go ahead and make sure I'm giving the correct sequence of values. The first one is going to be the year value, by the way. So that's 2013. The second is month, which is 5. The third is day, which is 8. The fourth is going to be the hour, which is 10. The second, let's say minute is 1 and second is 1. I'll just make this easy on myself. So that is the value I'm going to specify. and he says conversion of type to date time is not valid on this. So I'm not sure what the error here actually says. Now dot, oh, wait a minute, this is going to be, yeah, now is the right value that I want to get, isn't it? So not sure what the error in this case actually is saying. So cannot implicitly convert type date time to that value. Got it. So he's complaining that he's not able to shim this and replace this particular value here. That's what he's complaining about. Much like how I shimmed out this method, that's what I'm trying to do in this case, but I'm not sure why that error is showing up. Let me move this to the next line and see if it makes any difference at all. So that is the property that we're trying to change over here, right? So ideally, once we do that, we would have shimmed away the date time property, and as a result, when that error message is returned back, this would tell us that the value that it's returning would be on that date, because when the now is being called, it would return that particular value that we are expecting at this point, to reaching into the guts and removing things. But when you do take this approach, you can see how you can pretty much drive the entire code test driven. Once you finish this, you can get into the other code, which is talking to the web service, and you can start writing tests for it until the very last time when you can actually, I'm fine, don't mind me. So you can basically at some point, you can get to the point where you can replace the real implementation with the actual code and get down all the way to writing test driven. And once you finish that approach, of course, then you can quickly replace the solution with integration test and not go through the mock at all and do the integration test at that point. So this gives an ability for us to go all the way with test-driven development and not have to abandon testing. So mocking is something we got to be very careful about. So like I mentioned earlier, try not to use mocks whenever you can, but when the dependency is something very intrinsic, then start using mocking, but keep the mocks fairly lightweight, and then you can use tools. The problem today is not the availability of tools. The problem today is really dealing with complexity, but when used judiciously, I think we can do a fairly decent job in mocking. So I hope you found that useful. That's all I have.